Okay, hope everything went okay with yesterday's lesson. Today you'll see it says 1.3. Again, that doesn't matter to you so much. It's organizational for me. We're skipping 1.2 for what it's worth. It's not something we're just going to spend time on. So we are still in the vein of reviewing. This is not exactly Algebra 2 yet. There's skills that you'll use in Algebra 2. But today we're going to focus on solving equations. So that's where you isolate the variable in an equation. That can be isolated on either side of the equal sign, does not matter. There will be extra steps like combining like terms, distributing, things like that. And there are two special cases for solving equations, and actually this will come up over and over throughout the course. Some equations just have no solution. They can't be solved. And some equations can actually be solved by every number. When that happens, it's called all real numbers. And before we get going, I want to give you a little notation. If there is no solution to the equation, you can just write the words no solution. However, a common symbol is that circle with a line through it. It is not a zero, it is a circle with a line through it. And then a symbol for all real numbers. Again, you can write the words all real numbers. That means every number solves the equation. But also, if you make a capital R and then put another vertical stick on it, that looks weird. Let me do it this way. So two sticks, capital R, that stands for all real numbers. Mathematicians kind of love weird, obscure symbols, and that's one that's used a lot. I don't know if this is done in English anymore, but a capital P with two sticks on it represents the word paragraph. So it's kind of like that, but it's an R for all real numbers. Okay, this is going to start out really simple. Maybe you'll find the whole thing simple. I don't know. As I go through it, though, it's supposed to get more difficult as we go. So let's look at this. We need to solve this equation. B over 7 equals 8. And I'm going to rewrite it down here just so I have room to show my work. I wouldn't say you have to do this necessarily. You can probably figure this out in your head. If you don't show your answer on a simple one-step, we call this a one-step equation, I get it. What number divided by 7 equals 8? If you know your times tables, you know the answer is 56. But if you want to actually work it out, to isolate the b, you have to look at what's being done to it and do the opposite of that. The opposite of divide is times, so you need to multiply by 7. Then whatever you do on one side, you do on the other side, so you have to multiply this side by 7. That keeps balance. So over here, you look at the concept of multiplying by 7 and dividing by 7. Well, if you put this over 1, we had this concept last week called canceling. You have a 7 on top, 7 on bottom. They cancel out. That leaves you with b over 1, which is just b. So honestly, we can save a whole bunch of work and just say, oh, when you multiply and divide by 7, they cancel each other out. That's b. 8 times 7 is 56. And there's your answer. Easy peasy, just like we said the answer would be. Now, for consistency's sake, I'm going to scroll down and check my work. And there it is. 56, they put it in these little, these are called braces. You don't need to worry about that. Oops. If you want to do it, that's fine. All right, number 14. No, number 14. There's a 14 in it. I'm smart. Number 4. So we have 19 equals 14 plus n. Again, you could probably do this in your head. What can you add to 14 to get 19? And you're probably just saying, oh, 5. The answer is 5. Correct. Let me show you the steps just in case you need to review. It's been a while since you've done any kind of algebra. So you look at the 14 plus n. There's a positive 14 added to n. If you subtract 14, 14 minus 14 cancels out, makes it go away. And of course, you have to do the same thing on the other side of the equal sign. This equal sign sort of splits it. So 19 minus 14 is 5. Bring down the equal sign. 14 minus 14 is 0. Again, goes away. Bring down the plus n, the positive n. And that's it. That's the answer. So really basic, simple stuff. That is the type of problem where if you didn't show your work, I'd understand. There it is. So again, just stuff you may have not done for a while. Maybe you forgot over the summer or what have you. Okay, this problem will be a little more challenging for some people. There's a couple different ways to do it. I like to combine terms. The 8 minus 1, they're on the same side of the equal sign. You can just combine those. 8 minus 1 is 7. Okay, so you put those together. They're like terms, whatever. Now, we need to isolate the x. Some people see this minus sign, and they say, oh, opposite of minus is plus. I need to add 7 to both sides. Well, think about this. If you add 7, does 7 plus 7 cancel each other out and go away? They do not. 7 plus 7 is 14. The idea that you want to accomplish here is to isolate the variable. That means we want this 7 to completely cancel out and disappear. What does it take to get rid of a 7? That's going to take a negative 7. So don't look at the sign after the number. Look at the sign in front of the number. Of course, if there is none, that means it's positive. So we have to, let's get ink. We have to subtract 7 on both sides. 14 minus 7 is 7. Bring down the equal sign. 7 minus 7 is 0, negative x. Now, as we said, to solve an equation is to isolate the variable. This is not isolated. There is a negative sign there. 7 equals negative x is the same thing as 7 equals negative 1 times x. That negative sign can be thought of as a negative 1, which is multiplied or coefficient of x. And to cancel that out, you need to divide by negative 1. You may know a shortcut for this. I'm not going to get into it. 7 divided by negative 1 is negative 7. That should be our answer. And notice I don't have x equals negative 7. I have negative 7 equals x, but those are both the same answer. It doesn't matter. Let's look at number 6. Make sure I didn't mess it up. Yep, there it is right there. Okay, so combine like terms, isolate the variable, look at what's in front of the number when it comes to canceling it out, not what's after the number. All right, number 8. Again, we have a scenario here where we have like terms on the same side, so I'm going to combine those. Negative 4n plus n, this is like plus 1n. What's negative 4 plus 1? That's negative 3n. Now, can you do 2 minus 3 and get negative 1? I hope you said no, because they're not like terms. This has an n next to it. This one doesn't. You cannot combine those if they're not like terms. We need to isolate the variable here. So we start by subtracting 2 on both sides. Negative 3n equals negative 12. Now this negative 3 is attached to the n through multiplication, so we need to divide by negative 3. Negative 3 divided by negative 3 is 1. That's 1n. Negative 12 divided by negative 3 is 4. There's the answer to number 8. Everyone should have 4. There it is. This is a lot of scrolling up and down. I hope it doesn't bother you too much. Last spring, I did a lot of work where it was all crammed on 1 or 2 pages and no one had any room to write. So I'm trying to make a good effort to make sure every assignment has lots of space. All that means is I have to scroll up and down more. So, okay, number 10. So here's a case where you have to distribute. If you have a number next to a parenthesis, it means multiply. And we have multiple terms inside of the parentheses, you have to distribute it or multiply it by every term. So negative 7 times v is negative 7v. Negative 7 times, treat this like a negative 4. Negative times negative is positive 28. It's not technically a negative, it's a subtraction, but you can change it to plus a negative and then it all works out. Now to isolate v, I'm going to subtract 28. Again, review, this should be stuff that's like no problem for you. 84 minus 28 is 56. Check me on a calculator if you need to. And then this is negative 7 times v, so we end this problem by dividing by negative 7. And we get 56 divided by negative 7, which is negative 8. Sorry, that might have hurt your ears if you're using headphones. I'll try not to make that sound anymore. So number 10 should be negative 8. There it is. Only a couple more, but they get more complicated. So here we have parentheses on both sides, variables on both sides. This parenthesis over here has a negative 6, so like the last problem, we're going to distribute that negative 6. This one just has a negative sign. Negative signs do distribute. So a negative, negative 4, 2 negatives make a positive. Negative plus 2 is going to turn into minus 2r. Negative 6 times r, negative 6r. Negative 6 times negative 8, positive 48. So that was the distributive property on both sides. If you don't like the idea of distributing a negative, change it to a -1 and multiply it. -1 times -4, -1 times 2, and then you get the same result. It just depends on how you like to think about it. Okay, now we have variables on each side of the equal sign. There's no set rule as to how you need to do this, but I always like to focus on the variables first. So I'm going to ignore that 4 and that 48 for now. I'm just going to focus on the variables. And I'm going to, well, let's see. I don't like negatives, so I'm going to add 6r to both sides. You add because it's a negative, and that's what it's going to take to cancel this out. Do it to both sides, of course. -2 plus 6 is +4. So I'm just kind of thinking ahead here. This would give me a +4r. Had I decided to do it differently and add 2r to both sides, I'd end up with a negative number, and I really didn't want to do that. So bring down the 4, bring down the 48, and continue. How are we going to isolate this variable? I'll have to subtract 4 on both sides. 4r equals 44. 4 times r, so opposite of times is divide. Divide by 4, r equals 11. So from geometry, algebra 1, this should be stuff you fairly easily remember. Whoa, what did I just, whoa, wait, what? Did I skip a problem? I did, I skipped a problem. I'll get back to it in a second. Okay, sorry. Number 14, 11, just like we thought. So I got to go back and do number 12. It looks like the answer is going to be 0. So let's do number 12 and make sure we can get 0 for an answer. Parentheses here, I'm going to distribute -3m plus, not 4, so that's going to be 12. Let me try to make that a little neater. -12 plus 7m. Nope, screwed up. -3 times +4 is -12. Okay, I think I'm right here. All right, once again, I like negative numbers, so I need to get my, or I'm sorry, I don't like negative numbers. I need to get my variables together, so I could either add 3m to both sides, or I could subtract 7m on both sides. Subtracting 7m will give me a -10, and I don't like that. So I'm going to add 3m to both sides. -3m plus 3m, gone. -12 equals -12 plus 10m. Now that my variables are consolidated, I can solve or isolate. So I'm going to add 12 to both sides. -12 plus 12 is 0. Divide both sides by 10, and you get m equals 0. So that's what we said the answer was. I'm not going to go down and check it because we knew ahead of time the answer was going to be 0. Keep in mind, 0 is a solution. Sometimes people get 0 for an answer, and then they'll, for some reason, write no solution. Well, that's wrong. 0 is a solution. If you plug 0 into this equation, make this a 0, make this a 0, it'll work out. It'll balance. So 0 is the solution. All right, let's look at number 16. Kind of similar, starting off with a distributive property. -2 times n is -2n. -2 times -4 is +8. Now again, we need to get our variables together. So I'm going to add 2n to both sides. And I get 8 equals 7. The variable is completely gone. -2n plus 2n cancels here, and it cancels there. When the variable completely disappears out of a problem, that means it's a special case. There are 2 special cases, as I mentioned up here in the notes. There's a no solution and an all real numbers. So when the variable disappears completely, you should automatically think special case. Which one is it? Well, you just ask yourself a question. Does 8 equal 7? No, it doesn't. Therefore, this has no solution. If the variable disappears and you end up with a false statement, that means there is no solution. So we could go back to this original equation, plug any number you want in for n, plug every number in for n, and nothing will work. So say we plug in a 3. So over here, we get negative 2 times 3 minus 4. That's negative 2 times negative 1, which is positive 2. Over here, we get 7 minus 2 times 3. That's 7 minus 6. That's 1. Does 2 equal 1? No. So 3 is clearly not the solution. There's infinitely many numbers we could try. I'm telling you, none of them would work. This is a no solution problem. So let's look at number 16 just to make sure. Wow, wouldn't it be funny if I got it wrong? There it is. Number 18 is our last problem. We'll look at it ahead of time. You can see here, this one's going to be an all real numbers. So we've got to talk about what goes into an all real numbers type problem. Okay, so we got parentheses. We got this negative sign here. Again, you can treat that like a negative 1 if you want and distribute it. That's going to give you positive 8v plus 8. Bring down the minus 2 equals 6 plus 8v. We do have like terms here on the same side, so you just combine them. 8 minus 2 is positive 6. Now we have variables on both sides of the equal sign. We need to get those together. What does it take to cancel out an 8v? It's going to take minus 8v, and you have to do that on both sides of the equal sign. 8v minus 8v, 0, cancels out, you get 6. Over here, cancels out, you get 6. Just like the last problem, the variable disappeared. It's not anywhere to be found. That means this is a special case. Then you ask yourself the same question. Does 6 equal 6? Yes, it does. That means this is an all real numbers problem. So all real numbers is your answer, as you saw when we checked it down below. That means you can pick any random number, plug it in, and it will work. I'm going to pick 5. We'll just plug in a 5 for v. It's just some random number. Guaranteed it will work. So we get negative 8 times 5 minus 8 minus 2. Does that equal 6 plus 8 times 5? Okay, I could have picked a smaller number, but anyway, if I work this out, it's going to be negative 40 minus 8 minus 2. That's negative 40 minus 8, negative 48 minus 2. Negative turns to positive 48 minus 2, which is 46, kind of bleeding into my previous problem. Let's work out this other side. Well, this side's easy. 6 plus 8 times 5 is 40. 6 plus 40 is 46. Okay, that 4 looks like a 9. That could be confusing. We get 46 over here, 46 over here. The fact that it's the same answer, we call that a balance. That means that 5 is the solution. Now it means 5 is a solution. If I had plugged in 2 or 1 or negative 7 or any number, it will also work. So that's what all real numbers means. So no solution, no number, no matter what, would work. All real numbers, every number works. They look really similar. As you're doing the problem, the variable completely disappears. You either get a false statement, which means no solution, or you get a true statement. Maybe I'll write that down. True statement, which means all real numbers. I like the symbol, but you can write the words too. Up here, I like the symbol, you can write the words too. Whichever way you want to do it. Okay, I'm going to stop babbling. Do the odds as normal, check your work, show your work as much as is feasible. If you have any questions, send me an email or use the comments of Google Classroom. All right, talk to you later. Bye.